Hi guys, in this session we're going to continue with a mixture of multiplication, division and powers of powers. Let's get started straight away. So the example that I'd like to work with in this session is this one. Something that looks 4x to the power of 5 multiplied by 9x, and that's divided by 36 x to the power of 5. Now, as usual, we can actually do this two ways, but there is something new that I'd like to try. Some of you might have already seen this before, but anyway, I will explain to you why it is that I'm doing this. Now, since everything is being multiplied in the numerator and everything is being multiplied in the denominator, what I'd like to show is this. I'd like to write it a little bit more, almost like in an expanded way. So it's 4 multiplied by x to the power of 5 multiplied by 9 and multiplied by x, and that's divided by 36 multiplied by x to the power of 5. Now, in any rule, if you have in the numerator and the denominator a same number and all of them are getting multiplied, then what I could do is I could potentially say x divided by x to the power of 5 divided by x to the power of 5 is actually equal to 1. So I could potentially say that these two get cancelled out and get replaced with a 1. Now in the numerator also, 4 times 9 is 36, and because 4 times 9 is 36, I really should have actually done this in another color. Let's just try that. So 4 times 9 is 36, which means you also have 36 in the numerator and 36 in the denominator, which of course cancel out each other. So those three will cancel out each other to get replaced with 1. Which means in the end, all you really have for the final answer is simply just x by itself. There is actually more than one way to do this. I mean, you could actually multiply the numerators together and then divide it. I mean, really, with simplifying, you have more than one way to do it. I want to show the same example, but in a different method. So the different method is, so let's say we have that. We could actually expand the numerator out. We could actually do the numerator. 4 times 9 is 36, and x to the power of 5 multiplied by the x to the power of 1 is going to give you x to the power of 6, and all that is divided by 36 x to the power of 5. And of course 36 divided by 36, they're going to cancel out each other to end up with 1, which means you're left over with x to the power of 6 minus 5, and that's simply x. Now I'm sure there's a couple of other ways to do this as well, but I'll let you figure those methods out. One more example. This particular problem, I know a few kids have been having problems with. I'll write it down first. You have 6x cubed to the power of 4 multiplied by 3x to the power of 5. Now I'm just going to replace this multiplied with a little dot. It's just another format of writing multiplication. And in the denominator, I'm going to have 18x to the power of 9. And let's say that's being raised to the power of 5. Well, let's put in the powers of the numbers first, because 6 is going to have a power of 1. 3 is also going to be raised to the power of 1. And 18 is going to be raised to the power of 1. Now, one of the key things to notice is that, trying to do 6 to the power of 4 is going to be quite hard without a calculator, unless you're really good with your times tables. Or trying to do 18 to the power of 5 without a calculator is going to take you an incredibly long time. And I guess this is where you have your true understanding of powers of powers comes into play. And also, if you look at the numerator, you've got a 6 and a 3. And in the denominator, you've got 18. Which means you should know that there is a connection between these three numbers. And the connection is 6 multiplied by 3 is 18. So in other words, you can write 18 as 6 times 3. And that's what we're going to do. What we're going to do is we are going to replace 18, this 18 there, with a 6 and a 3. But so we're going to do the denominator real quickly. So we're going to have 6 multiplied by 3 multiplied by x to the power of 9, and all that is raised to the power of 5. And in the numerator, because we have 6, 1 times 4, and then we have x to the power of 3 times 4, and then on this side we have 3, where it's to the power of 1 multiplied by 5, and x, well, x is by itself, which means it's got a power of 1 as well. 1 times 5. So in the end, we can actually rewrite this as, we have 6 to the power of 4, x to the power of 12, 3 to the power of 5, and x to the power of 5. Now the denominator, I'm just going to work the denominator separately here. So if we have 6 times 3 times x to the power of 9, and all that is raised to the power of 5, then we have 6 to the power of 5, 3 to the power of 5, and x to the power of 45, which is the denominator. So I'm going to replace that with 6 to the power of 5, 3 to the power of 5, and x to the power of 45. Now, due to space, guys, I just have to continue to work in this space here. So what you've noticed now is that I can rewrite this as 6 to the power of 4, 3 to the power of 5, and x to the power of 17. And that's divided by 6 to the power of 5, 3 to the power of 5, and x to the power of 45. Now, from previously, we know that 3 to the power of 5 and 3 to the power of 5 cancel out each other to give you 1. And you would notice that with 6 to the power of 4 divided by 6 to the power of 5, you're simply going to have a 6 in the denominator, and x to the power of 17 minus the 45, you are going to have x to the power of 28. And so that's the final answer. Well, hopefully that wasn't an information overload there, guys. But that's all I have for this session. Thanks for watching.